So, after having tackled the introduction part of chemistry, now let's look at apparatus. Let's look at apparatus used in chemistry. Remember, now we say that chemistry deals with experiment, and in experiment, remember, we are using apparatus to carry out an experiment. So, most laboratory apparatus which are used are containers, and I remember they are made of glass. So we have a reason as to why most of them are made of a glass. So most laboratory apparatus which are used as containers and reaction vessels are made of transparent glass or plastic or plastic. So we are saying that they are made of glass or plastic. So you'll find that the most vessels or the containers that we are using are made of glass or plastic. So reason number one why they are made of plastic or glass is first for visibility. For visibility, remember a glass we can see through a glass. So for easy visibility. Then number two is that most of the glass do not react with the most of the chemicals. Do not react with most of the chemicals. So most laboratory apparatus which are used as containers and reaction vessels are of transparent glass or plastic, and we are saying that the reason why most apparatus in the laboratory are made of glass and plastic is number one, to allow one to see through while observing the reactions, taking place, or to determine the level of the liquids held therein. So remember, we will have to observe the reaction, but we will not look inside the glass through the open end, but we just see through because it is transparent. So you have just to see through the glass because of this transparency. Then we can that's while observing. Then we can also to determine the liquid held therein. Then number two, glass and plastic also do not react with most of the reagents used in the laboratory. Most of the reagents used in the laboratory. So those are the two reasons as to why most of the laboratory equipments are made of glass and plastic. So apparatus for measuring volume. So you have different apparatus for different purposes. Not each and every apparatus is used for one reason, but so each and every operator has the use they are used for. Each and every use they are used for. So you have those apparatus used for measuring volume. Have those apparatus used for measuring volume. Have those apparatus used for measuring volume. So all apparatus used for measuring volume of liquid are usually of transparent glass or plastic. So the apparatus used for measuring volume of liquids so you're saying that they are transparent, either glass or plastic. So the apparatus used for measuring volumes of liquids include so graduated beaker and flask. So you have either graduated beaker or graduated flask, have measuring cylinder, we have volumetric flask, have syringe, have pipette, have a burette. So those are some of the apparatus used for measuring volume. graduated beaker, graduated flask, measuring cylinder, volumetric flask, syringe, pipette, and burette. So you can see the diagram in which you have for this first one is a beaker, you have a conical flask, you have a measuring cylinder. So measuring cylinder can either be glass or plastic. Also same to the beaker. Conical flask is made of glass. So to measure approximate volumes. Now, remember, you can carry out an experiment where you are only needed to measure an approximate volume of the liquid that you want to use. So, graduated beakers or graduated flasks, measuring and measuring cylinder are used. Now, these are the ones that are used for approximate volumes. So, those are graduated beakers, flasks, and measuring cylinders are what are used, and measuring cylinders are used. So we have volumetric flask. Those are the diagram for each. Have the syringe, you have pipette, you have a burette, as you can see. Then apparatus for general use. Now the other ones have been for measuring the volume. Then we have now the apparatus for general use. Apparatus for general use. Let's see these apparatus that are for general use. That are for general use. Number one, we have a test tube used for general laboratory experiment. Can either be used in boiling liquid or a mixture of a liquid and a solid. Then you have a boiling tube used to in heating substances. You have a trough used for holding water for experiment, especially when collecting gas over water. Gas over water. So we have round bottom flask used to when heating liquid substances because heat is supplied uniformly so that flask does not crack as it expands. Now we are saying that the round bottom flask is used when heating substances because heat is supplied uniformly so that the flask does not crack as it expands. Then we have flat bottom flask used for general laboratory experiment. We have filter used for delivering liquid carefully into vessels. We have pistol funnel used for delivering liquid substances. We have separating funnel used for separating immiscible liquids. We have the dropping funnel used to add controlled amount of liquid into reaction vessel. So you can see the difference between the separating funnel. Separating funnel has a lid while the dropping funnel has no lid, but they all have taps. So we have conical flask used for general laboratory experiments and for measuring approximate volumes of liquids. Have reagent bottle used for storing bench reagent. So reagent bottle is used for storing bench reagents. So then you have wash bottles used to hold water for rinsing vessels and for adding water to vessels with narrow necks. We have teat pipette or dropper for delivering liquid dropways, used for delivering liquids dropways. Have evaporating dish used to an evaporating liquid. You have the spatula used for scooping solid substances from containers. Then we have gas jar used for gas collection. We have the desiccator. It's used for drying or keeping substances free from moisture. Have crucible used to heating solid substances that require strong heat. So we are still continuing with those apparatus that are used for general use. We have triangle, pipe clay triangle used for supporting crucibles during heating. We have wire gauge used for even distribution of heat when heating substances in beakers or flasks. We have tripod stand is used for supporting beakers and flasks during heating. Then we have mortar and pestle. They are used for crushing substances. We have the test tube rack. So the test tube rack used for holding boiling tubes and test tubes. Then the deflagrating spoon is used for holding substances being burnt. Now, for example, you are burning a solid, you just place it on a deflagrating spoon. You have a tongs safely used to safely hold corrosive or hot substances, hot solids. So now you are heating, so you want to hold a hot solid, you use a tongue or the substance that you want to pick is corrosive, you use a pair of tongue. Test tube holder used for holding test tubes when they are being heated. You have clamp and stand used for holding and supporting pieces of apparatus during experiments. Then you have those apparatus for measuring temperature. So temperature is measured using thermometers, and there are different types of thermometers. So temperature is measured using thermometers, and there are different thermometers. Remember that there are different types of thermometers as maximum and minimum clinical and general purpose thermometers, such as the one. So the one used for general purpose cannot. The one used for general, you have the one used for general purpose. Then you have the maximum, and minimum clinical thermometer. For example, the minimum and maximum thermometer has a maximum of 40 degrees Celsius. So we cannot use it to measure for example, we are boiling water, we cannot place it because it will burst. Because water boils at 100. Now this has a maximum of 40, so it will burst. So different types of thermometers, they are used differently. So like this one shown here is a thermometer. Then you have apparatus for measuring mass. You have apparatus for measuring mass. So mass is measured using weighing balances. There are different types of weighing balances, such as beam balances, electronic balances, and then top pan balances. Then you have apparatus for measuring time. The apparatus for measuring time are watches and clocks. Now, for accuracy during experiments in the laboratory, stopwatches and stop clocks are used. So remember, in laboratory, you want to know the duration that the reaction has taken. We'll either use a stopwatch or stop clock. Then now let's look at sources of heat. The pieces of apparatus used as source of heat include the Bunsen burner, spirit lamp, candle, gas, stove or portable burner, have kerosene stove, and electric heater. The Bunsen burner is the most suitable source of heat in laboratories. So, of all that we have mentioned, now the Bunsen burner is the most suitable source of heat in laboratory. So, we'll study it more. The Bunsen burner. We'll study more about this Bunsen burner. A Bunsen burner consists of three major parts, and these are chimney, the collar, and the base. Now this is the diagram of each. This is the diagram of the Bunsen burner, where it shows each. So you can see that in A here we have chimney, we have the collar. Collar has air hole. We have the base. The base has gas inlet and has the jet. So in B here, you can see it is now connected. So now the gas inlet, it's connected to the rubber tube. Now you have here chimney, you have the air hole here. So that's the Bunsen burner that we are talking about. Now let's look at the parts of the Bunsen burner. Those are the parts of the Bunsen burner: chimney, the base that has a gas inlet which is connected to the rubber tube. Then you have the collar. You have the collar. The collar has an air hole. The base has the jet and the gas inlet. Now let's look at the function of the different parts of the Bunsen burner. Now the base is made of thick metallic material in which a small hollow metal with a jet is fitted. Now the base, remember the base provides the base is heavy and wide to keep the Bunsen burner stable. Now the base provides stability on where the Bunsen burner can stand. So the base is heavy and wide to keep the Bunsen burner stable. And remember, the jet is on the base. The jet allows the laboratory gas into the chimney. So the jet allows the laboratory gas into the chimney. The gas inlet in the Bunsen burner is normally connected to an external source of laboratory gas by rubber tubing to let in the lab gas. Remember also the gas inlet is also on the base. Now the collar is the second part. It's a metal ring. Remember, the collar is just a ring. When now you open this, you'll find that they are divided into three parts. You have the chimney, the collar, and the base. So on the base you have the air hole, you have the jet. Sorry, the air hole is located on the collar. Air hole is located. They have the jet that is located. On the base. Base has the gas inlet, and the jet. Now the gas inlet is normally connected to the external gas. And then the jet now allows the gas to the chimney. Now the collar is a metal ring which may have an air hole whose diameter is the same size as that of the hole in the chimney. The diameter of the collar is slightly bigger than that of the chimney, so that the chimney can just fit into it. The collar is used to regulate the amount of air entering the chimney. So remember, we are saying that the air hole is located on the chimney. So chimney is just a ring that now regulates the amount of air entering the chimney. The collar is just a ring that now regulates the amount of air that enters the chimney. So it regulates the amount of air entering the chimney. It's just a ring. Collar is just a ring. So this ring is the one that connecting the base and the chimney that has an air hole. Now it regulates the amount of air regulates the amount of air. The chimney is a hollow metallic cylinder with an air hole near its lower end. Near its lower end. Near its lower end. So now just at the boundary between the chimney and the collar, so you have that air hole. So you have that air hole at the boundary of the chimney and the collar. So as we close, now we are minimizing the air getting in. So you'll find that the collar is just a ring on its own. The collar is just a ring on its own. Has nothing, just a ring. But now, when closing it, remember you are closing now the air hole that is on a chimney. The air hole that is on a chimney. The air hole in the chimney allows air to enter and mix with the gas from the jet. This mixture of gases, the laboratory gas and the air, when ignited, burn at the top of the chimney to produce a flame. Now, air hole allows gas in. Then we have the rubber tubing through the gas inlet, through the jet tubing that gets the gas into the gas inlet, down to the jet to the chimney. Then the collar that regulates the external air, that regulates now the air that enters the chimney, because the hole is found just at the base of the chimney. The base of the chimney, when we are opening the collar, because it's just a ring, it's just now it now regulates the amount of air getting in the chimney. So now the mixture of the gas from the laboratory and the air is what, when ignited at the top of the chimney, produces a flame. Produces a flame. Now, depending on the either the way you have opened depending on the way that you have opened this the collar, depending on the way that you have opened the collar, we have different types of flames that are produced. Have different types of flame that are produced. So types of flame produced by a Bunsen burner. Types of flame produced by a Bunsen burner. So before we look at the type of flame, now we have to understand what is a flame. So a flame is a mass of burning gases in air. A mass of burning gases in air. Remember, I have said that air is getting through the air hole at the base of chimney, then mixed with the gas through the rubber tube that is coming into the Bunsen burner by a burning tube through the gas inlet, then being directed to the chimney by the jet to be ignited to produce a flame on the chimney. Now, a flame is a mass of burning gases. A mass of burning gases. Now, when in use, a Bunsen burner produces two types of flame. When burning, a Bunsen burner produces two types of flames, depending on the amount of air allowed into the chimney. Now, the type of the flame that is produced depends on the amount of air allowed into the chimney. Now, the first type of flame is luminous flame. Luminous flame. So, the luminous flame is produced when the air hole is closed, such that no air enters the chimney of a Bunsen burner. So, we are saying that is produced when the air hole is closed. is produced when the air hole is closed. Now, the ring is adjusted so that no air gets into the chimney. No air gets into the chimney. So we are only using the laboratory gas. Only using the laboratory gas. So it's produced when the air hole is closed so that no air enters the chimney of the Bunsen burner. The luminous flame produces light because it contains unburnt tiny particles. The luminous flame produces light because it contains unburnt tiny particles of hot glowing solid carbon which give out light due to incomplete combustion. Remember now, the luminous flame is produced when the air hole is closed, so it is producing light because it contains unburnt tiny particles of hot glowing solid carbon, which give out light due to incomplete combustion of the gas, since there is limited supply of air. Now, due to limited supply of air, there is incomplete burning. So now there is production of light. To produce a luminous flame, connect the burner to a gas tap and close the air hole. So you can see the type of a flame that is produced when the air hole at the base of chimney is closed by the collar. So turn on the gas fully and light the burner. So remember, we are only using the laboratory gas. So the air hole is closed. The luminous flame, now we have the characteristics of luminous flame. So it is bright yellow, it is large and wavy, it gives out much light, Then a luminous flame has four zones. Then produces soot and burns silently. Burns silently. Now the blue zone occurs at the bottom of the flame because air near the flame rises rapidly and mixes with the burning gas. This makes burning almost complete. So air near the flame rises rapidly and mixes with the burning gases. This makes burning almost complete. The almost colorless zone of the flame consists mainly of unburnt gases. The luminous bright yellow zone consists mainly of unburnt tiny particles of hot glowing solid carbon which give out light. So the unburnt carbon particles form the black soot, which makes apparatus dirty during heating. Now because of the production of soot, which is due to incomplete burning, there is production of black soot, which makes apparatus dirty during heating. So air supply in the bright yellow zone is limited, and there is incomplete combustion of the gases. Now in the thin outer pale blue zone, the gas burns completely because it mixes with the plenty of air. However, this is normally difficult to see. Normally difficult to see. Now let's look at the luminous flame. This is now another type of flame that is produced. By the Bunsen burner. Remember, I said the luminous is produced when the air hole is closed. So the luminous flame is produced when the air hole of the Bunsen burner is open. When the air hole is open, air enters the chimney and mixes with the laboratory gas. There is complete combustion of the gas, and therefore the flame produced is pale blue. Complete combustion of the gas, and therefore the flame produced is pale blue. In color, pale blue in color. It does not give out much light because of the complete combustion. Now, to obtain an luminous flame, connect the burner to a gas tap to close the air, close the air hole. Turn on the gas fully and light the burner. Turn the collar gradually until the air hole is fully open. Now, we are saying that for us to get the luminous non-luminous flame, we fully close the air hole, connect the gas to the gas tap and close the air. Then we light. Then we start regulating we open the air hole until it is fully open, until the hole is fully open. Now we have the zones. We have the pale blue zone, those are for non-luminous flame. Have the green blue zone, then we have the almost colorless zone, almost colorless zone, almost colorless zone. Those are the zones for non-luminous. So the luminous flame also has characteristics. Number one, the flame has 3 zones. It is short and steady, does not give out much light due to complete combustion, then burns with a roaring sound, and then does not produce soot. So you can see the difference between the luminous and non-luminous flame. Now, the almost colorless zone consists of unburnt gases. The green-blue zone contains partially burnt gases due to insufficient supply of air. In the outer pale blue zone, the gases burn completely because there is plenty of air. The non-luminous flame gives out only a little light because it contains fewer hot carbon particles. Fewer hot carbon particles. Now, the heating effect of the luminous and non-luminous flame. Let's look at the heating effect now of the luminous and non-luminous flame. Now the heating effect of luminous and luminous flame. So this is an experiment that now we have to carry out. You light a Bunsen burner and adjust the color to produce a luminous flame. Then you pour 30 centimeter cubic of water into a 100 ml glass beaker. You heat the water in the beaker. Now that's how the setup is. You have the tripod stand. Then you have the wire gauge. Then you have the glass beaker. So this is for luminous. Then this is for non-luminous. So note the time it takes to boil the water. Now here you want to see which one is hotter than the other. So we repeat the experiment. Now the first one is said using luminous. Now we repeat the experiment using 30 cubic centimeter of water in an identical beaker and heat it with a luminous flame of the same Bunsen burner. So we have to use a stopwatch to see after how long it takes to boil for the luminous and how long it takes to boil for the non-luminous. In each case, observe the part of the beaker that was in contact with flame. Now we have to ask ourselves, which water sample took a shorter time to boil? Which water sample took a shorter time to boil? So water heated by an luminous flame took a shorter time to boil than the same amount of water heated by luminous flame. Now that's the difference, that the non-luminous will take a shorter time. It should take a shorter time. This shows that non-luminous flame is hotter than the luminous flame. Hotter than luminous flame. Then again we have to ask ourselves what was observed at the bottom of each beaker. What was observed at the bottom of each beaker? Remember we say that for an luminous flame does not produce soot, for the luminous flame to produces soot. Now we'll find that on the bottom of the beaker, or that was used for the luminous flame, it has soot. Then for the one for the luminous has no soot. Now the bottom of the beaker heated using the luminous flame is covered with soot, while the beaker heated using an luminous flame remains clean. So then then we have to explain now the observation. We have to explain the observation. Remember we said in chemistry we do experiments. We have to observe, analyze, interpret, then you make conclusion. Now so the water heated by a luminous flame took a shorter time to boil than the same amount of water heated by a luminous flame, because the non-luminous flame is hotter than the luminous flame due to complete combustion. Now the difference becomes due to complete combustion. Then now the luminous flame produces soot because due because presence of unburned carbon particles. So that's why it produces soot. So which type of flame is preferred for heating? That's also another question that we have to ask ourselves. Now because the non-luminous flame, it took shorter time, so that's the one that is preferred, non-luminous flame, because the non-luminous flame is very hot compared to the luminous flame. Another reason the non-luminous flame does not produce soot. So remember now it is an economical. You are using a flame that has soot, again you'll have again to go and wash the soot out of the apparatus that you have used to boil, and it also time consuming. Now the which flame is preferred for lighting? So luminous flames such as the candle flames and flame of lantern lamps are normally used for lighting because they give out light. So luminous flame is preferred for lighting. So which one is the most? So now we want to see which is the most hotter, which is the hottest part of luminous flame. We light a Bunsen burner, then adjust the color to obtain luminous flame. We slip a piece of white manila paper into the flame in region 1. Now, this is the image of what we are seeing. So, that's the region 1. That's the region 1 piece of paper, then we have the region 2. So, the results is as here. We have here then we quickly remove the paper before it catches fire. We slip a fresh piece of white manila paper into region 2 of the flame. Then quickly remove it before it catches fire. We now repeat experiment using a wooden spleen. Now for the wooden spleen, we let it stay in the flame until some of its parts get charred. Then we record our observation. Then you have some few questions to answer. So we draw diagrams to show how the pieces of paper and the splint were affected in region 1. That's the first one. So when a piece of paper is quickly slipped in and out of region 1 of the luminous flame, the paper is partly burnt in the region that is in contact with the pale blue zone. The middle part of the paper remains unburnt or no charred. So you can just see. So this is the region 1 for the part A, this is the region 2 for part B. Then we have now region 2 of the flame. When a piece of paper is slipped in and out of region 2, it burns uniformly. So then we draw the structure of the wood that we used in the region. When the wooden splints are used, instead of manila paper. Similar results are obtained. So you can see that you have at the center it is not charred, and for the region 2 it is charred uniformly. So we can make conclusion. The experiment shows the outermost zone inner and luminous flame is hotter than the inner one. Because now you'll find that for region 1 it was only charred outside and not at the center. So it means that the outer region is the one that is hot. For region 2, it was placed almost all of it in the outer region, and it was uniformly charred. So, which part of the flame is suitable for heating substances? Now, the outermost region of the flame, this is the hottest region of the flame because of complete combustion. Remember now the outermost region